Okay, so on Friday we were doing the distance formula. Yesterday we were translating line segments. Today we're going to do what's called copying line segments. Can somebody read for me the first paragraph on the page? In the previous problem.
In the previous problem, he translated line segments on the coordinate plane. The length of the line segments on the coordinate plane are measurable.
Okay, so if we're drawing something on the coordinate plane, you can measure the segments by counting the boxes. Okay, Brittany.
In this problem, we will translate the line segments when measurement is not possible. The basic geometric construction is called copying a line segment or duplicating a line segment. The construction is performed using a compass and a straight edge.
Okay, so highlight that for me, guys, because they're in bold for their vocabulary. Copying a line segment or duplicating a line segment using a compass and a straight edge. Okay, guys, so number one, you should just be drawing some circles, right? Different sizes, different shapes. You can hold down the compass. Mine is not very good.
Wait, different sizes, different shapes?
Not shapes, just different sizes. All the same shape.
Can you make different shapes?
No, you can make circles. Make a really big one.
No.
That one's going to go off the page. I'm going to make a really small one. Your circles can overlap, I don't care. But just practice drawing a couple circles. Okay, so number two, we're going to draw a circle with a given radius. First of all, who can tell me what the radius of a circle is? Half, yeah, it's...
Oh, has half of the diameter.
It's half of the diameter, and the diameter is what stretches from one point to the other, right? So the radius goes from the center to the edge of the circle. So number two says that point C is the center, and the line segment CD is the radius. So how would we construct circle C?
Draw a circle.
Draw a circle around it. So if C is our center, you're going to put your pointy end on C, and we're going to make the compass the same length as CD, and then we're just going to draw a circle around it. So it should look like this. There we go. Right? Your circle should look like that?
Yeah.
Where'd you get that?
So what I want you guys to do is do parts B, C, D, and E for me in your group. So part A says to draw points A, B, E, and F anywhere on the circle. So you should have picked points anywhere along the rim of the circle. I'm going to put A right here. I'm going to put B, I don't know, right here. And then what are the other ones? E and F. I'm going to put E really close to B. And I'm going to put F somewhere over here. Okay, so then what did the next part say? We wanted to construct AC, BC, EC, and FC. Do we already have a point C? So when we construct these, we should be connecting all of those points on the outside with point C. So your circle should have started to look kind of like a wagon wheel or a pizza with very, very uneven slices. Okay, so it should have looked something like that. Okay, then let's look at questions D and E, and you guys can share out your answers with me. What conclusion can you make about all of these line segments? Who found a conclusion about all of those line segments? Jonathan.
Well, they're all the same length.
Well, they are all the same length. Why?
Because they're equal to CD.
They're all the same length, or all the line segments are the same length. How do you know that they're all equal to CD?
Because we made a circle and CD is the radius of the circle.
So they all have the same distance from the center, right? Because they all have something like that. Okay, what about part E, somebody different or a different group? Do you think the line segments you constructed are also radii of the circle? How do you know? Radii is plural for radius. Different group, so sorry, Brittany. Different group. Do you think that all of those segments are also a radius of the circle? Emily, why?
Because they're all the same length.
Yes, because they're all the same length. What else? What's the definition of radius? Emily gave it to us earlier. Half of the circle, or it goes from the center to the outside. Do all of these segments go from the center to the outside? Yes. So they all extend from the center we call that an endpoint. So let's say to an endpoint on the circle. If what you wrote is not exactly like this, that's okay, as long as it's similar. If you missed something, add it into your explanation right now. Brittany.
An arc is a part of a circle. You can also think of an arc as the curve between 2 points on the circle.
Good. I would highlight that because it's in bold. So an arc is part of a circle. So that means if we were to, for example, on the circle that we drew earlier, took just a piece of it, maybe from point B to point D, that's considered an arc. So it's part of a circle, but not the whole circle. So what we want to do in number 3 is we have a circle or a center C, and the radius is AC. We want to construct an arc of circle C. We want to make it about 1/2 inch long and construct the arc so that it does not pass through A. So since we want to make an arc of the circle, we still have to open our compasses to the radius. So open your compass so that it's the same length as AC. Okay, but it says we do not want the arc to pass through A, so let's make it on the other side. So now that you have your compass the same length as AC, let's make an arc off to the other side. So something like this. Okay guys, so part B says to draw and label 2 points. So I'm going to pick any point on the arc. This one is going to be B, and this one is going to be, what did they say, E. And then the segment. So BC should look like this, and EC should look like this. And then the question said, what conclusion can you make about these line segments? Will you please turn to your neighbor right now and tell them what you wrote for part C? Amanda, what conclusion did you guys make? They all have the same length. How many of you got that they all have the same length? Who can explain to me why they all have the same length?
Because then, yeah, it's the same length as AC.
Okay, so Dana said, because they're all the same length as AC. Every single one of these points is the same distance from the center C. So write something like that, because they all are the same distance from C. Okay? Okay, so let's turn the page. I'm going to read because you guys are chicken. You will need your highlighter. Line segments that have the same length are called congruent line segments. That's a definition. Highlight that. And then they tell us what congruent means. Congruent means to have the same size, shape, and measure. Your compass should be on the same point, and you make a circle, and then it said to just pick a point and draw another one. So I did this one right here. Then you were supposed to mark points where the circles intersect and draw another circle using that as the intersection point, and then repeat that process. So here is where these two circles intersect, so I'm going to use that as my new center.
What? I forgot. Wait. You're supposed to only make three?
No, you're supposed to make it all the way around.
Oh.
So it should look like this. And then my new circle intersects right here. So I'm going to use that as my next center. Oops, wrong way. My thing's that same. And we're going to do it again.
Mine keeps moving.
Yeah. Here's my next point of intersection, and I think this should be the last one. Ah, mine keeps changing. I know. Oh wait, just kidding, we needed one more. And so then here's my last one. Or those should have intersected. Okay. My compass keeps moving too. Oh my gosh. Okay, it should have looked like this. I gave it. It should have looked like that. And if we connect all of the points in the middle of the circle, what shape do they make?
Okay.
How many sides does it have? 6, so that is a hexagon. So it should have made a hexagon. If we take all of our points that we drew right here and connect them, you can use your straight edge. That should make a hexagon. Okay? Make sense? Okay, turn it over. I know. Let's skip that page and let's go to the next page. So you should be on page 664. We're going to construct segments and then we're done. Okay, problem 4, another method. This one is actually the method that we've already learned on constructing segments, but it actually shows you in pictures, which I think is really, really good. So let's read through it really quick. Line segments can be duplicated while using a compass, but not drawing a circle. So what we were doing earlier was we were duplicating line segments by drawing a circle and then just drawing radiuses all over the circle. Does that make sense? So you can duplicate a line segment by making a circle, and then any point on the circle is a radius of the circle, which is the same length. We can do this idea without actually drawing the full circle. So if I want to duplicate segment AB, you take your compass and you measure it to the length of AB. We draw a line with a point C, and then we put our compass on point C and draw an arc. And since we know that that arc is the same length as AB, that point of intersection is also the same length as AB. We've done this, right? Okay, so let's do number 1 that asks us to construct a line segment that is twice the length of segment AB. So the first thing we are going to do is draw a line. Use your straight edge. Since it's a line, it should have arrows on both points, or on both ends. And let's call it A prime. So let's label a point A prime. So copying the segment AB should be easy, right guys? You put your compass on AB. So we know it's the same length as AB. And then put your compass on point A prime and draw an arc. And where those two intersect, put a point and label it B prime. Okay? Yeah. Now question. Is A prime B prime twice the length of AB? Or is it the same length as AB? It's the same. So how could I get a segment that is twice the length of AB? We take the measure and multiply it by 2, but we can't use a measuring tool. Jordan says if we just put the point that's the same length as AB on B and do the whole thing again, that will give us 2 segments that are the same length as AB, which means we have a segment that is twice the length of AB. So let's call it C prime. So A prime C prime is twice the length of AB because we made 2 segments of AB. Yeah, I would do A prime C prime with the line segment. And then let's write is twice the length of segment AB. Something like that, okay? So we would say A prime C prime is twice the length. So number 2, they give us 3 segments to duplicate. So what I would suggest, because there's not a ton of room, just make one long line. And along that line, just duplicate each of the segments. So start by duplicating UV, call it U prime V prime, and then go over a little bit and duplicate WX with W prime X prime, and then go over a little bit and duplicate YZ. Okay, so you can duplicate all 3 of those segments on the same line. That's fine. Okay, so to duplicate UV, I need to pick a point and call it U prime. Everybody should have got that, right? And then we make our segment the same length as UV, and then draw an arc on the line. Let's label that V prime. And now segment UV is the same length as segment U prime V prime. So next I want to duplicate WX. I'm just going to pick another point and label it W prime. Same length as WX. Make the segment and label it V prime. Everybody got that one? So now to do YZ, I just pick another point, label it Y prime. Open your compass to the same length. And that is going to be Z prime. Okay. So guys, Dave is copying segment AB, and he drew a circle around AB, and then on his line, he drew another circle around A prime and labeled the point B prime. Is that correct?
Look, yes and no, yeah.
Well, yeah, it's correct. He's doing the same thing. What did Sandy do that's different? She just made an arc. She didn't draw the whole circle. Which method is correct? Both are correct. So, because this actually the exact same thing. You just don't have to draw the whole circle. So what I want you guys to do right now before you go, explain to me which one is correct and why, and then answer number 4. Which method do you prefer? Do you prefer to make the whole circle, or do you prefer just to make the arc? So, with your groups, explain to me why both methods are correct, and then answer number 4. Which method do you prefer?